Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed first 9 questions from exercise 11.2. Hope you have revised well. In today's session, we shall discuss the remaining problems from exercise 11.2. Let's move on to the topic. Before starting the session, let's recall the formulae of lines in a plane. The first one is point parallel form. Vector equation is vector r is equal to vector a plus lambda into vector b, and the Cartesian equation is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Here a, b, c are the direction ratios. Instead of direction ratios, if direction cosines are given, means a, b, c can be replaced by l, m and n. Next, 2-point form. Line passing through 2 points whose position vectors are a and b. Vector form is vector r is equal to vector a plus lambda into vector b minus vector a. And the Cartesian form, when x1, y1 is z1 and x2, y2 is z2 are the 2 points coordinates are given to you, means the formula is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Next, condition for two lines to be parallel, that is vector b1 is equal to lambda into vector b2, or a1 by a2 equal to b1 by b2 is equal to c1 by c2. Their direction ratios are proportional, that is in Cartesian equation form. Next, condition for two lines to be perpendicular, that is vector equation are given to you, means vector b1 dot vector b2 must be equal 0. If the equations are in Cartesian form, the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. a1 a2 b1 b2 c1 c2 are the direction ratios. Instead of direction ratios, if direction cosines are given to you, means l1 l2 plus m1 m2 plus n1 n2 is equal to 0. Next, we learn about skew lines. Skew line means the lines which are neither parallel nor intersecting and they are lying in different planes, or non-coplanar. Shortest distance between two skew lines we have learned, that is there we have studied modulus together we have used, but here I'm just keeping separately because it is easy for you to calculate. Then both are same only. Modulus of b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2, and the Cartesian form is determinant x2 minus x1 y2 minus y1 z2 minus z1 a1 b1 c1 a2 b2 c2 divided by root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. Next, we have learned about distance between, or the shortest distance between two parallel lines. There also we use the modulus together while studying, but here using separately, so it's not a problem, both are same. Which one is convenient, you can use it, that one. Here distance is modulus of b cross a2 minus a1 divided by modulus of b. So you have to by heart these formulas, and not only by hearting, you must be able to identify a1 b1 c1 a2 b2 c2. Then when equations are given to you like this form, that is r is equal to a plus lambda b, means vector a and vector b you must be able to identify. Then direction ratios and direction cosines, x1 x y1 z1 x2 y2 z2, all these things you have to just know how to identify from the equations. Move on to question number 12. The question is, find the values of p so that the line 1 minus x by 3 equal to 7y minus 14 by 2p equal to z minus 3 by 2 and 7 minus 7x by 3p equal to y minus 5 by 1 equal to 6 minus z by 5 are at right angles. Here we have to find out the value of p. Two equations are given. The condition is they are at right angles. So when you closely observe the given equation of lines, 1 minus x by 3 equal to 7y minus 14 by 2p equal to z minus 3 by 2. Here 7 minus 7x by 3p equal to y minus 5 by 1 equal to 6 minus z by 5. This is x minus x1 by a, y minus y1 by b, z minus z1 by c, but they are not in standard form. So first of all we have to bring these two equations in standard form. That means x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Here, this is the standard form of the equation of that is one point and parallel, that is point parallel form is this one, x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So the given equations can be written in the standard form as x minus x1, x should be first, so we have to take a minus from here common. So when we take minus common, that minus we have to put it in the denominator. So x minus 1 by minus 3, first part solved. Next, y minus y1, coefficient of y should be 1, but here it is 7. We have to divide through 7. So here, when you are dividing the numerator and denominator with 7, 7y by 7 is y, and 14 by 7 is 2. Here, denominator also we have to divide. Numerator also 7 we have to divide, denominator also we have to divide. That is 2 by 7p or 2p by 7. Equal to, this is okay, no problem, z minus 3 by 2. So the first equation is in standard form. Second equation we have to change again, x minus x1, x should be first, coefficient should be 1. So x should be first in the sense we have to take a minus common, that we can keep it in the denominator, that is minus 3p. Then coefficient of x should be 1, means you have to divide with this 7. So when you divide through 7, 7x by 7, that is x. Then minus 1, this should be minus 7. When we take a minus outside, this is minus 7. So minus 7 by 7 is minus 1. Divided by denominator also, if you divide by 7, that is 3p by 7. That minus here is which we have taken from numerator, we are just putting with the denominator, because numerator coefficient of x should be 1. Equal to, this is okay, y minus 5 by 1. This is similar to y minus y1 by b. This is having some problem, z should be first, means you have to take a minus and put it in the denominator. So z minus 6 by minus 5. Now both the equations are in standard form. So two lines are perpendicular. Two lines are perpendicular in the sense, first of all we have to identify their direction ratios, and the sum of the product of their direction ratios must be equal to 0. So let's identify the direction ratios. A1 is minus 3, B1 is 2p by 7, and C1 is 2. Denominators are the direction ratios. Then A2 is minus 3p by 7, B2 is 1, C2 is minus 5. Since the given lines are perpendicular, as I mentioned before, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. A1, A2, that is minus 3 into minus 3p by 7 plus 2p by 7 into 1 plus 2 into minus 5 equal to 0. That is minus into minus plus 3 into 3 9 into p is 9p by 7. 2p into 1 is 2p by 7. Here 5 into minus 2, that is minus 10. This minus 10 we are bringing to the right side, that becomes plus 10. 9p by 7 plus 2p by 7 is equal to 10. So when you take 7 as common LCM, and after taking 7 common LCM, cross multiply it, 7 into 10 is 70, 9p plus 2p is 11p. So 11p is equal to 70. Finally we are getting p as 70 by 11. So the value of p is 70 by 11. First of all, here you have to keep it in mind. You have to observe the equation and convert it into the standard form. That is x minus x1 by a, y minus y1 by b, z minus z1 by c format. Then check the denominators a, b and c right, and using the condition find out the value of p. Next we shall discuss question number 13. The question is, show that the lines x minus 5 by 7 equal to y plus 2 by minus 5 equal to z by 1 and x by 1 equal to y by 2 equal to z by 3 are perpendicular to each other. The two lines are given to you. First of all, you have to verify, or we have to check whether these lines are in standard form or not. If not, you have to convert it. Then you have to use the condition a1, a2 plus b1, b2 plus c1, c2 equal to 0. Then you have to prove that the lines are perpendicular. So this question you will try it as homework. Move on to question number 14. The question is, find the shortest distance between the lines r is equal to I cap plus 2 j cap plus k cap plus lambda into I cap minus j cap plus k cap, and vector r is equal to 2 I cap minus j cap minus k cap plus mu into 2 I cap plus j cap plus 2 k cap. We have to find out the shortest distance between the lines. So we have to write the given lines. The first line is written and the second line also we have copied. Then we have to compare it with the vector r is equal to a plus lambda b. It is quite clear from the given equation itself. It is quite clear that it is in the form a plus lambda into b. So we are comparing with the general form, that is point parallel form. Vector r is equal to vector a plus lambda b. We can write, since there are two lines, we can write a1 b1 and a2 b2. Here a1 is I cap plus 2 j cap plus k cap and b1 is I cap minus j cap plus k cap. Then a2 we can write second one 2 I cap minus j cap minus k cap, and b2 is 2 I cap plus j cap plus 2 k cap. The shortest distance between the lines formula, that is d is equal to modulus of b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2. So first of all we have to go for finding the b1 cross b2, that is b1 cross b2 is equal to b1 and b2 are here, this written. Then first row ijk, determinant first row is ij and k. Then second row we will write as first vector components, that is 1 minus 1 1, it is written here. Next one is third row will come as the second vector's components 2 1 2, it's written. Then we will go for expanding that, is I cap into that row and column is gone, minus 1 into 2, that is minus 2, again minus 1. So minus 2 minus 1 into I cap. The next symbol is minus j cap into that row and column is gone, 1 into 2, that is 2, minus again 1 into 2 2. So minus 2 into j cap plus, here k cap is the third element, k cap, if you take that row and column is gone, 1 into 1 1, then minus into minus plus, 2 into 1 is 2, so 1 plus 2 into k cap. Then we will go for little bit of calculation. Minus 2 minus 1 into I cap, that is minus 3 I cap. Then this 2 minus 2 becomes 0, that means j cap is gone. 1 plus 2, that is 3 into k cap. So b1 cross b2 we have got. Next we have to go for modulus of b1 cross b2, that is we want it for the denominator. So modulus of b1 cross b2 when you calculate root of x square plus y square plus z square. Here y is not there, so x square and z square we can take minus 3 the whole square plus 3 the whole square, that is equal to minus 3 the whole square is 9 and 3 square is 9. Then that is 9 plus 9, that is equal to 18. So 18 we can split as 9 into 2. When 9 comes out of the square root, it becomes 3. So 3 root 2 is magnitude of b1 cross b2. Then d we can use, d formula directly we can use now because most of the things we have calculated. So d is equal to b1 cross b2. b1 cross b2 we have calculated here, minus 3 I cap plus 3 k cap. So minus 3 I cap plus 3 k cap dot a2 minus a1. So here it is a2 and a1 we have written. Let's subtract and write, that will be easy and it will be reduced one step. So 2 minus 1 is 1. So 1 into I cap is I cap. Then minus 1 minus 2. Minus 1 minus 2 is minus 3 j cap. Here minus 1, again here minus 1. So minus 1 is minus 2 k cap. Then just to take the dot product. While taking dot product, it is quite clear that just multiply the components. So minus 3 into 1. Minus 3 into 1 is minus 3 into 1 we can write. Later we can go for simplification. Then here j component is not there. In this one j component is not there, but here j component is there, no need to take. Then 3 into k cap and minus 2 into k cap. So when you take, that is 3 into minus 2. 3 into minus 2, it's written here. Then denominator is 3 root 2 as it is. Then minus 3 into 1. Minus 3 into 1 is minus 3. Then here 3 into minus 2 is minus 6. So minus 3 minus 6 is minus 9. Minus 9 divided by 3 root 2. Modulus of minus 9 divided by 3 root 2, that is equal to 3 and 9 you can cut 3 times. So 3 divided by root 2, modulus value means without sign will come out, that is 3 divided by root 2. So since the denominator is in irrational number, we have to rationalize. Just multiply root 2 in the numerator and denominator. That is 3 by root 2 into root 2 by root 2. That is equal to 3 root 2 by root 2 into root 2 is 2. So the shortest distance between the two lines is 3 root 2 divided by 2 units. Next we shall discuss question number 15. Find the shortest distance between the lines x plus 1 by 7 equal to y plus 1 by minus 6 equal to z plus 1 by 1 and x minus 3 by 1 equal to y minus 5 by minus 2 is equal to z minus 7 by 1. Go through the equations. First you have to identify whether the given equations are in Cartesian form or vector form, because there are two formulas we have studied for shortest distance. One is in vector form, another one is in Cartesian form. So here it is quite clear the equations are in Cartesian form because it contains x, y and z terms, just like an algebraic expression or algebraic equation. So the given equations we have written, then compare it with the general form x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Then we have to write x1, y1 and z1. When you compare here, there is a plus sign, but here there is a minus sign. So you have to split it, this one, x minus minus 1. Here also same, here also minus 1. So x1, y1, z1 will be minus 1, minus 1, minus 1. We are splitting z minus minus 1. So that minus 1 we have to take. Denominators a1, b1, c1. That we can take. A1 is 7, B1 is minus 6, C1 is 1. Likewise, the second equation if you consider, here nothing to change because already in standard formula x minus 3, y minus 5, z minus 7, all minus signs, everything is fine. Just pick and write. x2 is 3, y2 is 5, z2 is 7. Denominators are a2, b2, c2, that is 1, minus 2 and 1. Go for writing the formula. D is equal to determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 divided by root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. While explaining this formula, I told you that there is a shortcut or a short form. By using that, we can recover the formula if you forget. Better to by heart it, this one. So we can use the alphabets C, A, B, C, A, B, 4 alphabets. If you read in Hindi, it is Bakab. So Bakab is the word, B, C, A, B is the spelling. First of all, denominators, you have to write only the alphabets, the product of the alphabets. No need to write this 1, 2, 2, 1 digits. So first we have to start with BC. I'm not putting any numbers here, only the alphabets. BC I am taking, writing BC minus BC. Next two alphabets, CA. I am writing CA minus CA. Next I am taking the last two, that is AB. So AB minus AB. Once again, first BC I have taken, I wrote here BC minus BC. Next CA I have taken, I have written here CA minus CA. Next AB I have taken, I have written AB minus AB. Then just fill in the numbers 1, 2, 2, 1. Again 1, 2, 2, 1. Again 1, 2, 2, 1. The whole square. So that is the way you have to recall if you or recollect it if you forget the formula while solving the questions. Then just take the distance formula as equation number 1 because we are going to split it this one. Otherwise the calculation will be a little bit lengthier or more space we need to calculate. So just taking numerator and denominator separately. Numerator if you take x2 minus x1, that is determinant, 3 minus minus 1, that is 4, y2 minus y1, 5 minus minus 1, that is 6, 7 minus minus 1, that is 8. If you write it in proper way, calculation will be very easy to, or else we have to go for searching where is x1, where is y1, like that. So if you write it in proper format, it will be easy for you to calculate. A1 b1 c1 is here, 7 minus x1, a2 b2 c2, 1 minus 2, 1 is calculated. Go for expansion, 4 into row and column is gone, minus 6 plus 2. Then minus 6 into row, column is gone, 7 minus 1 is written. plus 8 into row column is gone, minus 14 plus 6 is written. That is, here minus 4 into 4 is minus 16. Here 6 into 6 is 36. There is a minus sign outside. Here again minus 14 plus 6 is, here minus 14 plus 6, that we will get 8. 8 into 8 minus 8 into 8 is minus 64. So when you add it together, we will get minus 116. That is the numerator value. Then we will go for the denominator calculation. Root of b1 c2 b2 c1 the whole square, c1 a2 minus c2 a1 the whole square, a1 b2 minus a2 b1 the whole square. That also we can do little bit easy way, like a cross multiplication way we can go. b1 c2, b1 and c2 is here, minus 6 into 1, that is minus 6, minus b2 c1 is here, minus into minus plus, so 2 into 1 is 2. c1 a2, c1 is here, a2 is here, 1 into 1 is 1. c2 a1, that is 7 into 1, 7, minus 7 the whole square, plus a1 b2, here a1 is 7, b2 is minus 2, so 7 to minus 2, minus 14. a2 b1, a2 is 1, then here b1 is minus 6, so minus into minus plus, 1 into 6 is 6, minus 14 plus 6. That is equal to calculation, root 16 plus 36 plus 64. That is equal to root of 116 we will get. This root of 116 we can split, factorize, that is root of 2 into 2 into 29. That is, out of these two, 1 2 will come out, 2 root 29 will come. Question number 1, you substitute d is equal to, numerator we calculate as minus 16, denominator we calculate as 2 root 29. Here minus 58 by root 29 we will get, because you are cancelling 2 and 116. Then denominator, if you check, it is in irrational number format, just rationalize it. That is, or else you can just simply do like this. 58 we can split it. 58 when you split, you will get us 2 into root 29. Sorry, 2 into 29. Two way we can do it. First one, either you rationalize the denominator. Here it is a root 29. Just multiply 29 numerator and denominator. That is one way. Or else 58 you split it. That is the way we are going to do now. Minus 2 into 29. Then here 29 and root 29 we can cancel it. Root 29 into root 29 is 29. So from there root 29 is cancelled. So numerator is balanced, 1 root 29, here minus 2. So minus 2 root 29. So modulus of d, actually here modulus we didn't write while writing the formula. Finally we are taking the modulus. Modulus of d is equal to 2 root 29. So the distance between the given line is 2 root 29 units. Move on to question number 16. The question is, find the shortest distance between the lines whose vector equations are vector r is equal to I cap plus 2j cap plus 3k cap plus lambda into I cap minus 3j cap plus 2k cap, and vector r is equal to 4i cap plus 5j cap plus 6k cap plus mu into 2i cap plus 3j cap plus k cap. So this question you will try it as homework. Move on to question number 17. The question is, find the shortest distance between the lines whose vector equations are vector r is equal to 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap, and vector r is equal to s plus 1 into I cap plus 2s minus 1 into j cap minus 2s plus 1 into k cap. Here when you look at the question, or when you observe the given equations, it is not in the proper format. The proper format should be r is equal to vector a plus lambda into vector b. Means a vector a should be there plus lambda, a constant, into another vector. But here everything is grouped here. I components, j component and k components are grouped and written as a single vector. So let's write the given lines equations and we have to regroup it. Vector r is equal to 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap. Here I components with constants, that we can take as one vector, and t is a constant we can consider, and t we have to take outside like lambda. Then the remaining terms we can form the another vector. Let's group it. That is vector r is equal to constant and the components together. Here I into 1, that is 1i. that means I cap. Here 2 and j, minus 2 and j, that means minus 2j. Then here 3 and k cap, that is plus 3k cap, plus instead of lambda here t is there. That t we can take as common. T if you take outside, here there is minus 1. So minus 1 into I is minus I, plus j. Here it is t is there, and since t is outside there is only 1. 1 into j, that is j. Then here minus 2t is there. T outside going means minus 2 into k cap. So this is in the form a plus lambda into b. Again another equation is given that we have to take. Vector r is equal to s plus 1 into I cap plus 2s minus 1 into j cap minus 2s plus 1 into k cap. Then here also we have to regroup it like this. First of all, with constants and I cap, j cap, k cap we can take. So here 1 into I, that is I cap. Then here minus 1 into j, that is minus j cap. And here there is minus into plus minus, minus 1 into k cap, that is minus k cap. Plus instead of mu here s is there. So s we can take s into, here s into I, s is outside, means here there is only 1 into I cap, that is I cap. Here 2s was there, s going out means 2 balance. So 2 into j, that is 2j cap. Here 2s was there, minus 2s. 2s is outside, so minus 2 into k cap. This is also in the form r is equal to a plus mu into b. So both the equations we have changed into the proper format. Now shortest distance formula we know, d is equal to b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2. So this formula we have to use and find out the shortest distance. Before that we have to find out this is b1, this is b2, then here this one is a1 and this one is a2. So just find out all these things and substitute it into the formula and find out the shortest distance. So this you will try it as homework. Let's recall the formulae of lines in a plane. The first one is point parallel form. Vector equation is vector r is equal to vector a plus lambda into vector b, and the Cartesian equation is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Here a, b, c are the direction ratios. Instead of direction ratios, if direction cosines are given means a, b, c can be replaced by L, M and N. Next, 2-point form. Line passing through 2 points whose position vectors are a and b. Vector form is vector r is equal to vector a plus lambda into vector b minus vector a. And the Cartesian form, when x1, y1, z1 and x2, y2, z2 are the 2 points coordinates are given to you means the formula is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Next, condition for two lines to be parallel, that is vector b1 is equal to lambda into vector b2, or a1 by a2 equal to b1 by b2 is equal to c1 by c2. Their direction ratios are proportional, that is in Cartesian equation form. Next, condition for two lines to be perpendicular, that is vector equation are given to you means vector b1 dot vector b2 must be equal 0. If the equations are in Cartesian form, the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. a1 a2 b1 b2 c1 c2 are the direction ratios. Instead of direction ratios, if direction cosines are given to you means L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Next we learn about skew lines. Skew line means the lines which are neither parallel nor intersecting and they are lying in different planes or non-coplanar. Shortest distance between two skew lines we have learned, that is there we have studied modulus together we have used, but here I'm just keeping separately because it is easy for you to calculate. Then both are same only. Modulus of b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2, and the Cartesian form is determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 divided by root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. Next, we have learned about distance between, or the shortest distance between two parallel lines. There also we use the modulus together while studying, but here using separately, so it's not a problem. Both are same. Which one is convenient, you can use it, that one. Here distance is modulus of b cross a2 minus a1 divided by modulus of b. So you have to by heart these formulas, and not only by hearting, you must be able to identify a1 b1 c1, a2 b2 c2. Then when equations are given to you like this form, that is r is equal to a plus lambda b means vector a and vector b, you must be able to identify. Then direction ratios and direction cosines, x1 y1 z1, x2 y2 z2, all these things you must know how to identify from the equations. Now let's discuss the basic concepts of plane. A plane is a flat two-dimensional surface that extends infinitely far. In the picture, there is a portion of plane is shown, and by using this definition, we can say that this portion or this plane can be extended infinitely far. Means we can extend upwards and we can extend downwards, we can extend towards left and we can extend towards right. So a plane is a flat two-dimensional surface that extends infinitely far. A plane is named by 3 points in the plane that are not on the same line. If I consider 3 points A, B and C which are on this plane, provided these A, B, C are not in the same line, then we can use these 3 letters A, B and C for naming this plane. The plane shown in the figure can be named as plane ABC. Every plane is defined by its normal. We have already learned about normal. Normal in the sense a line or a vector which is perpendicular to the given plane. A line or a vector which is perpendicular to the given plane is called its normal. And if you consider this flat surface, or if you consider this plane, there are infinitely many vectors which are on this plane. This is one vector, this is another one, this is the third one, and this is the fourth one. So there are infinitely many vectors, and we must note that there is no relationship between these vectors which are on the plane other than being on the same plane. So, and if you consider a normal in the sense a vector or a line which is perpendicular to the plane, means angle between the plane and the line must be 90 degree, then we can call it as a normal. There is a relationship between this normal and the vector which is on the plane. There is a relation, and this relation we are using for finding out the equations of the plane, and this is the basic concepts for forming the equations of plane. I repeat, there is a relationship between the vector which is on the plane and the normal towards the plane. And the relation is the dot product of these two vectors, means the vector which is on the plane and the normal. The dot product of these two must be equal to 0 because they are perpendicular. The angle between these two is 0. So this is the basic concept. We must keep it in mind. All the lines on the plane will be perpendicular to a common line. We call it as normal. I have already explained this concept. And next is general equation of the plane. This you have already learned in class 11. The general equation of the plane is ax plus by plus cz plus d is equal to 0, where a, b and c are the direction ratios of normal to the plane. Normal to the plane means this one. Next, we shall discuss the equation of a plane. There are 5 equations we have to learn. The first one is normal form. If vector ON is the normal from the origin to the plane and n cap is the unit normal vector along ON. If you observe this diagram, vector ON is the normal from the origin to the plane. Vector ON, this is a normal. We have already explained about the normal. So normal means a line or a vector which is perpendicular to the given plane. So here ON is the normal vector and n cap is the unit vector along ON. N cap is the unit vector along ON. Means if you want to find out vector ON, we have to multiply this unit vector with its magnitude d. D in the sense the distance of this point n from the origin, that is d. So when you multiply the magnitude d with n cap, we will get vector on. Let P be any point on the plane. I have taken one point P, coordinates x, y, z. These coordinates we are not going to use now. When we are deriving the Cartesian form, we will use this x, y, z. At present, we will take only the point P, and the position vector of P is vector r we have taken. So NP, vector NP is perpendicular to vector ON. As I have discussed before, NP is a vector which is on the plane and ON is a normal. So a plane or a vector which is on the plane and a normal towards the plane, both are perpendicular, means their dot product is 0. That is vector NB dot vector ON is equal to 0. So let's find out this vector ON first. Vector ON I have already discussed before. Unit vector along ON is given to you, that is n cap, and the distance is given d, or the magnitude is given d. So when you multiply the magnitude with the unit vector, we will get the vector ON. ON is equal to d into n cap. Then vector NP in the sense position vector of P minus position vector of N. Position vector of P we have marked here, that is vector R, minus position vector of N. Position vector of N in the sense ON. ON we have already calculated, that is D into N cap. So let's substitute it. That is vector NP dot vector ON is equal to 0. Vector NP we have calculated, that is vector R minus D into N cap dot vector ON. Vector ON is D into N cap is equal to 0. And here D must not be 0. A dot product is 0 in the sense either R minus D into N cap dot N cap, means these are all vectors, this must be 0, or D must be 0. D, of course, it is not possible to get as 0 because D is the distance of that particular point N from the origin. So since D is a distance, D must not be equal to 0. That means vector R minus D into unit vector N dot N cap must be equal to 0. Then let's take the dot product, that is vector R dot N cap minus D into N cap dot N cap is equal to 0. That is R dot N minus D into N cap dot N cap, that is equal to 1. So this minus D, when it comes towards right, it becomes plus D. So R dot unit vector N is equal to D. This is the vector equation of the plane in normal form. And now we have to move on to calculate or finding out the Cartesian form. We can use these P, X, Y, Z coordinates. So let P, X, Y, Z be any point on the plane, and L, M, and N be the direction cosines of unit vector N. So once again, P, X, Y, Z be any point, arbitrary point on the plane, and L, M, and N be the direction cosines of N cap. Then OP, that is, we can calculate OP, that is the position vector of P. Position vector of P we can write, since the coordinates are there, X, Y, and Z. So Xi plus Yj plus Zk, that is vector R is equal to Xi plus Yj plus Zk, and N cap is equal to Li plus Mj plus Nk. Since they are unit vectors, so we can use the direction cosines L, M, and N. So N cap is equal to Li plus Mj plus Nk cap. Then when we substitute it, we will get R is Xi plus Yj plus Zk. We are going to substitute it in vector equation. R dot N is equal to D. R dot N cap is equal to D. So vector R is Xi plus Yj plus Zk dot, then N cap is Li plus Mj plus Nk is equal to D. That is, when we do the calculation, we will get it as Lx plus My plus Nz is equal to D. You know how to take the dot product, and I dot I and I dot j values we have to substitute, and we will get the final answer as Lx plus My plus Nz is equal to D. And this is the Cartesian equation of the plane in normal form. These proofs are not explained in the examination point of view, but if you know how to derive it, this one, it will be easy for you to solve the given questions in the examination. That is the purpose of explaining this derivation. Next, we have to note an important point for solving questions in the examination. If d is the distance from the origin and L, M and N are the direction cosines of the normal to the plane through the origin, then the foot of the perpendicular is LD, MD and ND. Foot of the perpendicular means the coordinates of the foot of the perpendicular can be calculated by using the formula LD, MD, ND. Here D is the distance from the origin. L, M and N are the direction cosines of the normal to the plane through the origin. If you visualize it, the foot of the perpendicular, this is the plane and the distance is given to you, that is d, and the foot of the perpendicular means the coordinates of the foot of the perpendicular means you have to find out the coordinates of this particular point. So this is called the foot of the perpendicular. So this is the visualization of that particular statement. Next, in the equation of plane, we will discuss point normal form. In the space, there can be many planes that are perpendicular to the given vector, but through a given point P, x1, y1, z1, only one such plane exists. The meaning of this statement is quite simple. There can be many planes that are perpendicular to the given vector. In the three-dimensional coordinate system, there can be many planes. If a perpendicular vector is given to you, there can be many planes which are perpendicular to the given vector. But a perpendicular vector and a particular point is given to you means there will be only one such plane exists. Let's visualize this statement. The three-dimensional coordinate system x, y and z axis and origin is here and a perpendicular vector is marked, and through this perpendicular vector we can consider infinitely many planes. Here of course 3 are shown here, but if you extend this vector infinitely far, then we can include infinitely many planes which are perpendicular to the given vector. But if you consider a point on the plane, that is P, x1, y1, z1, there will be only one plane which is perpendicular to the given vector and passing through that particular point. So we are going to form the equation of those planes which are perpendicular to a given vector and passing through a given point. So equation of a plane perpendicular to a given vector and passing through a given point. Let's observe this diagram. Here also derivation little bit I am explaining because it will be useful for you to solve the questions in the examination, but the derivations will not be asked. Here x-axis, y-axis and z-axis we have marked and the origin is here and there is a plane is mentioned, is shown here in the diagram, and there is a particular point in the plane, that is x1, y1, z1. A is the given point in the plane. The coordinates of A we have taken as x1, y1 and z1, and the position vector of A is vector A, and there is another vector is given to you, normal vector, that is vector n, which is perpendicular to the given plane. So these are the conditions, given conditions. A perpendicular vector is given to you and a passing through point is given, and the position vector of OA we have marked as A. As before, we will take another arbitrary point, that is P, x, y, z, a general or a common point in the plane, that is P, x, y, z. And in the beginning, I have already explained to you a vector, that is AP, which is on the plane, will be perpendicular to the normal to the plane. Means vector AP and vector n are perpendicular, means their dot product is 0. That is a concept we are going to use, that is vector AP dot vector n is equal to 0. Vector AP, we know that position vector of P minus position vector of A. Position vector of P we have taken as vector R and position vector of A we have taken as vector A. So vector R minus vector A. Let's substitute it. AP, the vector AP is vector R minus vector A dot vector n is equal to 0. Let's mark it as equation number 1, and this is the vector equation of point normal form. Now we have to find out the Cartesian form. For that, let the given point A be x1, y1, z1 and P be x, y, z. A is the given point x1, y1, z1 and P is the arbitrary point or a general point. And direction ratios of vector n are capital A, capital B and capital C. Direction ratios. Let's substitute in equation number 1. That is equation number 1 in the sense vector r minus vector a, position vector of r minus position vector of a, position vector of r in the sense here x and here it is x1. So x minus x1, that is the direction ratio. So x minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap dot. Here direction ratios are there, a, b and c, capital A, capital B and capital C. So vector n will be a into I cap plus b into j cap plus c into k cap is equal to 0. So when you pair it or when you solve it, we will get as a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the Cartesian equation of the point normal form. Next, in the equation of plane, we will discuss equation of a plane passing through three non-collinear points. Let's observe the given diagram. There is a three-dimensional coordinate system. X, Y and Z axis are marked and the meeting point of these three axes origin is also mentioned here. And there is a plane and we have taken three non-collinear points, that is R, S and T. Three non-collinear points we have considered, point R, S and T. The position vector of R we have taken as vector A, position vector of S is vector B and position vector of T is vector C. And we have taken a fourth point, that is arbitrary point or a general point P. The position vector of P we have taken as vector R. Let R, S and T be the three non-collinear points on the plane with position vectors vector A, vector B and vector C respectively. Now little bit of explanation is needed here. If you consider vector Rs and vector Rt, the cross product of vector Rs and Rt will be a vector which is perpendicular to both vector Rs and vector Rt. By using the definition of cross product, we can say that when you take the cross product of two vectors, we will get a resultant vector which is perpendicular to both the given vectors. Once again, if you take the cross product of Rs and Rt, vector Rs and vector Rt, we will get a resultant vector which is perpendicular to both Rs and Rt. Now you know that Rs and Rt are on the plane. And if you get a perpendicular vector in the sense that vector will be perpendicular to Rs and Rt. In the sense that vector will be perpendicular to the plane itself. And we have got Rs cross Rt now as a single vector. And there is another vector here Rp. And this vector Rp and this cross product vector, that is vector Rs cross vector Rt, these two are perpendicular because now this vector Rs cross Rt is the normal vector and Rp is the vector which is on the plane. And the dot product of these two vectors, this Rp vector and Rs cross Rt vector, the dot product of these two vectors will be 0. So that is the concept behind this equation of a plane passing through three non-collinear points. So let's write it. Rp dot vector Rs cross vector Rt is equal to 0. Once again, first we have taken the cross product of Rs and Rt. So we have got a resultant vector, that is Rs cross Rt, which is perpendicular to both vector Rs and Rt in the sense which is perpendicular to the plane itself. Then we will consider this as single vector. Vector Rs cross vector Rt we will consider as a single vector and Rp is another vector. So these two vectors are perpendicular. Because of that, their dot product must be 0. That is vector Rp dot vector Rs cross vector Rt is equal to 0. So once you substitute here, you will get that formula. That is vector RP we can calculate position vector of P minus position vector of R. Position vector of P is vector R and the position vector of R is vector A. So R minus A dot RS. Vector RS we can calculate. Vector RS in the sense position vector of S minus position vector of R. So position vector of S is B and position vector of R is A. So B minus A cross vector RT means position vector of T minus position vector of R. Position vector of T we have got here vector C and position vector of R. Position vector of R is vector A. So cross vector C minus vector A is equal to 0. So this is the vector equation of a plane passing through three non-collinear points. So instead of by hearting, if you know how to derive this formula, then it will be fine. Next we have to go for the Cartesian form. For that, let x1 y1 z1, x2 y2 z2 and x3 y3 z3 be the coordinates of the points R, S and T. R, S and T we have taken the coordinates x1 y1 z1, x2 y2 z2 and x3 y3 z3. Then we have taken an arbitrary point that is P. The coordinate is x, y and z. X, y, z be the coordinates of any point P on the plane. That is a general point. Then the equation of the plane passing through three non-collinear points can be found by using this equation. Determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. This is the Cartesian equation of a plane passing through three non-collinear points. Next, in the equation of plane, we will discuss intercept form of the equation of a plane. Let the plane AX plus BY plus CZ plus D is equal to 0 make intercepts A, B and C on X, Y and Z axis respectively. Hence the plane meets X, Y and Z axis at A 0, 0, 0, B 0, 0, 0, C respectively. Let's visualize it. So a plane meets X, Y and Z axis at P, Q and R respectively. Since here the meeting point is on the x-axis, only x value will be there, the other coordinates values will be 0. Here Q is at y-axis, so y value will be there, the remaining x and z values will be 0. And in z-axis, the point R is marked, so only z value will be there, x and y coordinates will be 0. So the intercept form is x by a plus y by b plus z by c is equal to 1. X by a plus y by b plus z by c is equal to 1. Now the last one, plane passing through the intersection of two given planes. Equation of plane passing through the intersection of two given planes. It's quite simple one. Here two planes, pi 1 and pi 2 are the two planes and pi 3 is the third plane which is passing through the intersection of pi 1 and pi 2. Let pi 1 and pi 2 be the two planes with equations r dot n is equal to d1 and r dot n2 is equal to d2. The equation of the plane passing through the intersection of the given planes is r dot n1 minus d1 plus lambda into r dot n2 minus d2 is equal to 0. So this one is quite simple equation if you really understand how to write. This is the equation of first plane and lambda into this is the equation of the second plane. When you bring this one to the left side, r dot n1 minus d1 equal to 0. So first one, simply we can say that p1 plus lambda p2 equal to 0. That we can say, no problem. p1 in the sense equation of the first plane plus lambda into equation of the second plane equal to 0. This is called the vector equation, and Cartesian equation is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equal to 0. It's also similar to the previous one only. Cartesian equation of the first plane plus lambda into Cartesian equation of the second plane is equal to 0. This is the Cartesian form of equation of plane passing through the intersection of two given planes. Next we shall discuss the condition for coplanarity of two lines. Two lines vector r is equal to vector a1 plus lambda into vector b1 and vector r is equal to a2 plus lambda into vector b2 are coplanar if vector a2 minus vector a1 dot b1 vector b1 cross vector b2 is equal to 0. The condition is vector a2 minus vector a1 dot vector b1 cross vector b2 is equal to 0. This is the vector form, and the Cartesian form is determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. Next, how to find out the distance of a point from a plane. The formula is modulus of vector a dot vector n minus d divided by modulus of vector n. The length of the perpendicular from the point P x1 y1 z1 to the plane ax plus by plus cz plus d is equal to 0 is modulus of ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This is the formula for finding the length of the perpendicular from a particular point to the plane ax plus by plus cz plus d is equal to 0. Next, we shall discuss distance between two parallel lines. First one is, it is a vector equation modulus of d1 minus d2 divided by modulus of n vector. Here, r dot n is equal to d1 and r dot n is equal to d2 are the planes. This is a vector equation of the planes. Next one is the Cartesian form, that is modulus of d1 minus d2 divided by root of a square plus b square plus c square. Here, the equation of the planes are in the form ax plus by plus cz plus d1 is equal to 0. Ax plus by plus cz plus d2 is equal to 0 are the planes. Next, we shall bring the formulae for planes under one frame. First one we have learned, that is normal form. Vector equation is vector r dot unit vector n is equal to d, and the Cartesian equation is lx plus my plus nz is equal to d. Next one we have learned point normal form, that is vector form vector r minus vector a dot vector n is equal to 0. Cartesian form is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Next one, equation of a plane passing through three non-collinear points. The vector form is vector r minus vector a dot vector b minus vector a cross vector c minus vector a equal to 0. And the Cartesian form is determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Next is intercept form. Plane cutting off intercepts a, b and c from x, y and z axis is x by a plus y by b plus z by c is equal to 1. Next one is plane through intersection of two planes. That is vector r dot vector n minus d1 plus lambda into vector r dot vector n2 minus d2 is equal to 0. This is the vector form, and the Cartesian form is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equal to 0. Next, condition for two planes to be parallel. When it is in vector form, vector n1 cross vector n2 is equal to 0 vector, or vector n1 is equal to lambda into vector n2. If it is in Cartesian form, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Next one is condition for two planes to be perpendicular. In vector form, vector n1 dot vector n2 is equal to 0. In Cartesian form, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Next condition for a line and a plane to be parallel. Vector n1 dot vector n2 is equal to 0. And a1 a2 plus b1 b2 plus c1 c2 is equal to 0. This is for Cartesian form. And here these two conditions are same. Condition for two planes to be perpendicular and a condition for a line and a plane to be parallel. Both are same condition. Next one is condition for a line and a plane to be perpendicular. That is vector n1 cross vector n2 is equal to 0 vector, or vector n1 is equal to lambda into vector n2, or else a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Here also condition for two planes to be parallel, and a condition for a line and a plane to be perpendicular. Both are same conditions. Then next one, condition for two lines to be coplanar. The condition is vector a2 minus vector a1 dot vector b1 cross vector b2 is equal to 0. This is the vector form. And if it is in Cartesian form, determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 is equal to 0. Next, distance between a point and a plane. Vector form is modulus of vector a dot vector n minus d divided by modulus of vector n. And the Cartesian form is ax1 modulus of ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This formula also can be used to find the length of the perpendicular from a particular point to the plane. Dear students, today we have learned the basic concepts of plane and the equations of plane under different conditions. I request all the students to go through each and every point carefully, and after learning the equations of plane, please make a comparative study between the equations of line and the plane. While learning, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.